Okay, this hour we will continue the introduction of IEEE 802.11 wireless LAN. Okay, you can see that we have a table right here. That is the evolution of different 802.11 standard from the very first B protocol G, N, ACX, AF to H. And you can see that the maximum data rate increase. Okay, so of course there are some new protocol mechanism to help the new protocols to enhance their maximum data rate. But also, as we mentioned before, new protocols they can utilize multiple antenna, and they can use a wider band channel, wider frequency band. So you can see that the maximum rate starts from 11 megabit per second to several gigabit per second. For example, Wi-Fi 6. Currently we have Wi-Fi 6 machines, so it is quite a it is a very big progress of wireless transmission, right? And the range is from 30 meter to 7 meter. Okay, and the frequency band, we have talked about frequency band because 2.4 gigahertz, it is free to use. Okay, so many different protocol. Okay, they use the free 2.4 gigahertz frequency band. Okay, and of course there are some other even newer protocol, but we don't use them currently. Okay, they are future standards. Okay, so all of them use CSMA CA mechanism for multiple access because in a wireless environment, okay, multiple access is usually the most important things you have to consider to design such kind of protocol, wireless protocol. And they both have base station mode and 8-hop mode. Okay, so let's take a look at this one. Okay, so previously when we introduced wireless access point, wireless base station, usually that looks like this. Okay, so wireless host communicates with base station. So BS stands for base station. Okay, so here we have a BS1 and here we have a BS2. Okay, so base stations, of course, in wireless architecture, base station stands is access point. We usually use access point to represent the base station in L2.11 architecture, and for each access point, they will have a BSS, basic service set. That means in this range, the base station can reach out all the underlying devices, mobile devices. They can serve those devices. Okay, and in this architecture, we also call it infrastructure mode. That means in this BSS, okay, we have a you can say that we have a AP, or say we have a master. Okay, so all the other mobile device, they have to associate with this master, to associate with this access point, so that their traffic need to go through this base station to the internet. Okay, so right here, for example, let's we have two different settings. For example, if it is switch, okay, if it is a switch which is attached after the server base station, as we mentioned before, because switch is a layer 2 device, so this base BSS1 and BSS2, they are under the same subnet. Okay, so maybe there should be a router right here. So all those devices in BSS1 and BSS2 and the switch, they belongs to the same subnet, so they will have the same network ID, NAT mask. Okay, that's one of the setting. Okay, one of the configuration. But another configuration is that if we have if those base station are attached to a router like this. So in these cases, the BSS1 and BSS2, they are separate subnet. So one BSS belongs to has one subnet. So we have two subnet right here. So as you can see that it depends on what kind of device, layer 2 device or layer 3 device is attached to the base station. So it's not necessary that one BSS is a subnet. It is not necessary to be so. Okay. So that is the ad hoc mode. That is the infrastructure mode. We have a master here. We have a base station act as a master, so they can control the state, all the underlying devices. Okay. The other one is the other one is ad hoc mode, but okay, we talk about ad hoc mode later. Okay. So in infrastructure mode, a new devices need to associate with access point. So basically, in infrastructure mode, spectrum divided into channels at different frequency, as we mentioned before. L2.11 at 2.4 gigahertz, it has 11 channels. Okay, so the access point admins they choose different frequency for different access points. Because we have interference problems, so the channel selected by the admin can be the same or can be different. As we mentioned before, again, we have 3 non-overlapping channel in L2.11, 22.4, 2.4 gigahertz, 1, 6, and 11, right? So the network administrator should select non-overlapping channels for those access point. But sometimes, everyone just simply buy the access point from Amazon, and they don't do any customized configuration. So basically all of the access point, they operate at channel 1, so it will increase the chance of interferences. Okay, so next bullet. Okay, arriving host must associate with an AP in infrastructure mode. It is the necessary thing you have to do. You have to associate with access point. So basically, the mobile device, okay, need to scan all the channels. So for example, it has to scan all 11 channels at 2.4 gigahertz, right? So they scan the channels and listen for beacons. So that is the important mechanism that access point will broadcast its information and all the parameters they used for their communication in a very specific layer 2 frame, which is called beacon frame. We will show you the packet of the frame later by using Wireshark. Okay, so all the information about this access point is in the beacon frame, and the access point will periodically broadcast the beacon frame in the channel. So when the new arriving host, okay, enter a BSS, it will scan all the channels, and eventually it will receive the beacon frame from the access point, and the beacon frame contains the AP's name, which is called SSID, okay, and the MAC address. Okay, so the MAC address right here, usually we have another terminology called BSSID. Okay, that is the basic service set identifier, right? And because it is an identifier, so it should be uniquely identified, the BSS set. So usually we use the MAC address of the AP, the Wi-Fi interface, the MAC address of the Wi-Fi interface of the of this AP as an uniquely as a unique identifier, so that we can distinguish different AP and their basic BSS. Okay, and the name right here is the SSID. It can be set, configured by the network administrator, and as you know, in campus, in our campus, in NCCU, our SSID is NCCU Wi-Fi, right? And U-Wi-Fi. And this name, it is not this SSID is not necessary to be unique. So you can set any I think any English word which is okay, characters which is okay to name your AP, but the BSS ID should be a unique value. So MAC address is used. So then they may perform authentication mechanism. So usually you need to provide ID and password to access to associate with the access point. But we will not go over this authentication mechanism in this class. Okay. So and then you associate with the AP. So the underlying layer 1 and layer 2 is connected, and then at layer 3 you need to obtain IP address. So further you can send your DHCP packet. Okay. Make sure you remember that DHCP is a UDP diagram. Okay. So you can send a UDP which is encapsulated in your layer 2 frame, and your layer 2 frame is already has been set by the association mechanism. Okay, we'll talk more about the association later. Okay, so but right here I would like to show you something about the frame, the beacon frame, and we have and again we you can download these two Wireshark packet in our class website. Okay, one is the ARP packet. We talk about ARP packet last chapter, right? So I'd like to show you something about this ARP packet. Okay, so I think I believe I captured this ARP packet last year. Okay, so you can see that we have several let's see. Okay, I would like to show you how our packet is encapsulated and what is the information included in our packet. Okay, so of course ARP is a layer 2 mechanism, so it should be embedded in a layer 2 frame, right? So let's take a look what a layer 2 frame looks like. So it is an Ethernet frame. Okay, so Ethernet frame header is very simple. So we have a destination, MAC address, which is a broadcast because it is our ARP request. So basically the ARP request is something like this. That means I am C@FF 28B5 4A9F. That is my MAC address. Okay, so my IP address is 192.168.50.124, and I would like the purpose of our protocol, our packet, is to query what is the MAC address. Okay, it's right here. Yeah, right here. The purpose of our packet is that I know what is my IP address. I know what is my MAC address, but I'd like to know what is the MAC address of a IP in the subnet. So basically the request right here, the request which is ARP request, which is attached in the Ethernet frame. Okay, it is specified who am I. I am this 124. Okay, that is my MAC address. I would like to know the MAC address because I don't know that MAC address, so I simply just use 00000 in this field. Okay, but I would like to know what is the MAC address of 50.42. So that is a ARP packet, and in order to broadcast this packet or this frame to the entire subnet, so at layer 2, the destination MAC address is broadcast all FFFFF, and the source is myself, that is C8FF, is exactly the same as this one. Okay, and I specify this frame is a ARP packet, and here's the request. So we have some value right here, and it is a request. So this Ethernet frame, okay, will be broadcast in the channel, in the wire, right? And since its destination MAC address is broadcast address, so every network interface card in this Ethernet subnet will receive this frame, and all the network interface card will get this frame and see, okay, that is the broadcast destination. So let's see what is inside this Ethernet frame, and it said, okay, it is an ARP. So this frame will be handled by some other program in your operating system, and it said, okay, it is an ARP request, and they will check if the target IP address is its own IP address. If it is not, then this frame will be dropped by the network interface card. But if the packet, if the IP address in this ARP request is exactly your IP address, and then you should send the frame out, which is an address resolution protocol reply. Okay, and in this reply, you should specify your MAC address right here. That is my app. That is the network interface card who sent the request, right? That is C8FF, okay, and its IP address is 50.124, and okay, which means 50.42, okay. I need to reply this ARP, right, and specify my MAC address is 3C2860 blah 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 blah. Okay, and this ARP information will be attached after an Ethernet frame, right? So right here, the destination is unicast, which means it is sent. Of course, the signal is broadcasted in the Ethernet channel, but the destination right here is a unicast. That means it has a specific destination MAC address, which is sent to the people who ask ARP request, right? And the source is the network interface card who answer this question. Okay, so that is a pair of ARP. One use broadcaster to request information about 50.42, and the answer is 50.42. Answer the question. The answer is right here. It's its corresponding MAC address. So by doing so, that we can know the structure of Ethernet frame, and this is an example of ARP protocol. That's how they do ARP request and ARP reply. Okay, that is one of the example. The other one I'd like to show you is about L2.11. Okay, and as we mentioned before, if you capture the frame of Ethernet, the frame of Wi-Fi, okay, you can see that there are several different types of packet, different types of frame. Okay, right here again, and the first one I'd like to show you is this one. It's the beacon frame. As we mentioned, right? So the access point will send the beacon frame periodically to the channel so that a new arriver, the new arriving host, can hear the beacon frame so that it can understand what is the parameters, what is the structure, what is the speed, what is the channel used by this access point. So let's take a look at the frame. So in the beacon frame, okay, there are some interesting field right here. For example, this access point, okay, that is a D-link, right? That is a D-link access point. So I think that is a access point of my neighbor, okay, because I captured this AO2.11 frames in my at my home, okay. So the beacon frame will be sent at a very low rate, which is 1 megabit per second. And my neighbor, okay, this access point use channel 1, okay, the first channel in at 2.4 gigahertz, right? The frequency rate is 2412 megahertz, right? That is 2.4 gigahertz, right? So my network interface card, okay, my Wi-Fi card can sense the signal strength, can sense the noise strength. So that is a signal to noise ratio, okay. The unit is dB, okay. So that is some information about this radio information. Also, the beacon also has some other information like that, because the beacon frame is broadcasted to all the other to broadcast in the channel, so everyone can receive such information. So the receiver, the destination address is all FFFF. The transmitter right here, that is the Wi-Fi MAC address of the access point. So specify A0, AB, blah 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 blah. Okay, so right here we can see that there's a field specify the BSS ID, and as mentioned, the BSS ID should be should be a unique value, because this BSS ID represents this BSS, this basic service set. So usually we use the MAC address of the Wi-Fi access point. So that is exactly the same as this one. Okay, so there are some other information. For example, right here, beacon interval. So the beacon will be sent to the channel every 0.1 second, something like that. So if you are a new arriving host in the BSS, you simply just stay at the channel for a while, and you can listen. You can hear this beacon frame. Okay. And again, we have some other interesting parameters right here. For example, that is the SSID set by the administrator. Then the name is D-Link, something like that. Okay, and it supports, I think that it supports L2.11b transmission rate 1 to 5.5, 11 megabit per second, and it is, I think it is also L2.11n access point, so it supports even higher transmission rate 6, 9, 12, 18, 24 to 55, and so on and so forth, something like that. Okay, and for example, we have some other interesting information, but we will not cover all those things. So I recommend you download the L2.11 this workshop file from our class website and take a look at these interesting things. Okay, there's some other interesting parameters right here. So that is the reason why you can your Mac or your Windows or your iPhone can scan the Wi-Fi channel to obtain some very interesting information, because all the information is embedded in this beacon frame. Okay, let's go back to the slide. Okay, so that is how a new arriving host to get information about an access point. So we have a passive scanning. So the first step is that because AP will periodically send the beacon frames out. So when you arrive at BSS, you can always sense those beacon. Okay, so you can then associate with the access point by using another frame called request frame. Okay, for this example, the H1 select one of the BSS. I don't know, BSS1 or BSS2, and then the access point will send a response frame back to the H1, the arriving host. So after that, the access point and the arriving host, they both know what is the parameter they should use and what is the rate, what is the channel they use. So there too is done. Okay, and at the right hand side, if you do, I mean, if an arriving host does not get the beacon frame, sometimes the arriving host cannot get the beacon frame. That is because you can configure AP that they do not periodically send the beacon out, because you can hide. I mean, the access point can hide itself. So sometimes the arriving host can send a prop request frame broadcast to a specific SSID. So if your access point indeed is configured using the same SSID name, and then the access point can reply the prop response frame to the host, and then the host can associate with the access point. Sometimes for the security consideration, we will turn off the beacon mechanism in the access point, so that users, I mean your neighbors, okay, your neighbors cannot get the information about your access point. That most of the time we turn off the beacon mechanism is because of the security issue. Okay, so you can use a passive scan, you can use an active scan, but if when you use the active scan name, you have to know the name of the access point. I mean the host, the arriving host must know the SSID name in prior. Okay, and again, as I mentioned many times, multiple access is a very important things we should do in wireless protocol. Okay, so the left figure we have shown you left figure, right? Because unlike Ethernet, in Wi-Fi environment, okay, we have a hidden terminal problem, right? So when A can talk to B and C can talk to B, but A and C may not sense A and C cannot sense the signal mutually. Okay, so we have hidden terminal problem. So CSMA, sense before transmitting, cannot guarantee collision does not happen. Cannot guarantee collision will not happen. So we should have some new mechanism to deal with the hidden terminal problems, to deal with the signal problems, because collision signal may not be sensed by all the other host in the BSS. Okay, that's a very critical problem. So L2.11, okay, collision detection may not quite useful right here. Okay, so difficult to sense collisions it may be due to high transmission signal, weak receive signals due to the fading. They cannot sense all the collisions. In any cases, for example, hidden terminal problems, fading problems. So the goal of Wi-Fi is to design another mechanism called CSMACA. Okay, carrier sense multiple access collision avoidance. Okay, so in Wi-Fi we should avoid collision. Unlike Ethernet, Ethernet can tolerate collision, and we have random backoff mechanism to recover the collision. But in Wi-Fi, we don't do so because it's it is pricey to deal with the collision problem. So in L2.11, we use CSMA-CA, collision avoidance. Okay, we'll stop the video right here. We'll continue discuss what is CSMA-CA.